Ever looked at an exam question and wondered what exactly separates a good answer from a perfect, full-mark answer? Well, you're in the right place. Today, we're going to pull apart a classic gas pressure question from a recent AQA GCSE Physics paper. By the end of this, you'll know precisely what examiners are looking for. Let's dive in.
Okay, so here's our focus. Question 9 from the June 2023 higher tier paper. It all starts with this picture of someone pumping up a car tire. We're going to go through all three parts of this question, and I'll show you the exact wording from the official mark scheme that would have scored you every single point.
So, how do you make sure you bag every last mark? It's not just about knowing the physics, It's about using the exact keywords and building your answer in the way that examiners are trained to look for. Let's break down how to do it.
Right, let's kick things off with question 9.1. It's a pretty straightforward one-mark question, but hey, every mark counts. Getting this one right sets us up perfectly for the trickier parts that are coming up next.
So, the paper asks you to complete this sentence. Air particles in the tire move quickly in blank directions. It's just a fill in the blank. What's the single word you think they're looking for?
And the magic word is random. Yep, that's it. Straight from the mark scheme. It perfectly describes that chaotic, unpredictable movement of gas particles. You write that one word, and that mark is yours. Simple as that.
But here's something interesting. The examiners weren't super strict on this one. While random is the best scientific term, they also gave the mark for all or any. So you actually had a few different ways to get that point on the board.
Okay, moving on to 9.2. The difficulty is about to ramp up just a little bit. This is a 2-mark explanation question, which means we need to give 2 clear, separate points to get the full credit. It's not enough to know it, you've got to explain it.
The question asks us to explain why the pressure goes up when you pump more air in. But, and this is so important, look at the huge clue they give you. They state that the volume and the temperature do not change. That tells you exactly what not to talk about in your answer.
So to get both marks, your answer needs 2 key ingredients. First, you have to state the obvious starting point. There are simply more air particles in the tire now. That's your first mark. Second, you have to link that to the consequence. This leads to a greater number of collisions with the tire walls per second. Boom, that's your second mark.
And hey, just like before, the mark scheme gives you a bit of wiggle room on that second point. You could say that collisions are more frequent, or there's a greater rate of collisions. As long as you get that idea of more often across, you're getting that mark.
Now, this is absolutely crucial. This is the trap that lots of people fall into. The mark scheme explicitly says, do not mention particles moving faster or the temperature going up. Why? Because the question told you temperature is constant. It's a classic mistake, so watch out for it.
All right, time to tackle the final boss of this question, 9.3. This is the big one, worth a whopping 4 marks. To nail this, you can't just throw keywords at the page. You have to build a perfect, step-by-step, logical argument.
So, the task is to explain why pressure increases when the temperature of the air goes up. This is a fundamental physics concept, and the examiners want to see if you can connect the dots in the right order.
Think of this as a 4-step chain reaction. Here's how you get all 4 marks. Step 1. A higher temperature means the particles have greater mean kinetic energy. Step 2. Because they're moving faster, this leads to more collisions with the tire walls per second. Step 3. Not only are there more collisions, but each collision hits with a greater force. And finally, Step 4, a greater force spread over the same area means, you guessed it, greater pressure. You need to show that whole logical chain.
And once again, the mark scheme gives you options. For that first point, you could just say particles move with greater speeds. For the second, more frequent collisions works fine. For Step 3, if you want to sound really smart, you could say greater rate of change of momentum. And for the final point, greater force on a given area is perfect. Knowing these alternatives can be a real lifesaver.
So when you boil it all down, what's the secret sauce here? It's really 2 things: using those precise keywords the examiners are looking for, and then linking them together in a logical cause and effect sequence. If you can master that, you are absolutely golden.
Seeing it all broken down like this, from the mark scheme's point of view, really makes it click, doesn't it? The real challenge, though, is can you take this same technique, hunting for keywords, building that logical chain, and apply it to the next tough physics explanation question you come across? Think about it.